Hello everyone, how are you? Hope all you are doing fine. Now we will have sheet number 3 for the fins, heat transfer through the fins. We want to make a quick revision before we start. That the heat transfer through the fins, there is 3 shapes for the heat, the shapes, the long rod, the rectangular, and the last one is for the triangle. Okay? There is some quick points we want to share with you for solving. You have to know this is the rod or the body or the hot surface. Okay, when the mention for the temperature, this is the hot body, this is the hot surface, this is the one who got the temperature inside T inside or TS. Okay, for the surrounding, this will be the surrounding or the environment, and there is another word we can use, surrounding environment or the atmosphere. Okay, you have to notice this. The efficiency, if you in the triangle, in case of triangle shape, in triangle shape, it is the only one that we use the equation for the efficiency in the triangle shape. Okay, and we assume the efficiency by 0.98. In case the efficiency is required, we recalculate the equations. We calculate the normal Q and we calculate this to calculate the efficiency, if the efficiency is required. If it's not required, in case of triangle only, we use this equation. The other thing that I want to make sure that you understand it in the rectangular. Okay, in the rectangular, there is something called Z or W. Z or W, it is the cross section, it is the width of the fin. Z or W, it is the width of the fin. If it's not required, if it's not given, you make assumption that it's equal 1. Z or W, it's the width of the fin. If it's not required, you assume it equal 1. There is something else called the corrected length. The corrected length. Okay? The corrected length, it is the LC. In case this line is cancelled, we will not, to make it easier for you, we will not get you shapes with cylindrical. It's only with rectangle. So you have to study that the corrected length equal length plus thickness over 2. Okay? Sometimes we make assumption that the length corrected equal the length actual. When we use this or when we use that, it's all the same. So if you want to make it, it's better for you to calculate the corrected length. If you forget it, you can use the actual length, no problem. Okay, and sometimes in the sheet you will find us make that assumption L length, the corrected length equal the length. Otherwise, you will find us solving like this. Both are correct. Okay, we go to the sheet. The first thing with us. The first one, a very long copper rod having a thermal conductivity of 372. So the first thing you write the thermal conductivity equal this. And 2.5 centimeter diameter. 2.5 centimeter diameter. Centimeter, you multiply by 10 negative 2. 10 negative 2 to make it meter. Okay, then has one end maintained at 90 degree. Has one end maintained. Therefore, in this case, the temperature for the body, or TP or T surface, it will be the 90 degree. The rod exposed to a fluid whose temperature is 40. So it's supposed to liquid here. Okay, temperature is 40. Therefore, T infinity, it will be 40 degree. the heat transfer coefficient is equal 3.5. Calculate the heat given up by the rod. So we write down the givens, and the required is the Q, heat transfer. How to answer? First of all, we have to know that this is a rod. So we write the equation for the rod, that the Q equal root HPKA multiplied by delta T. Area for the rod, we take it that it's equal pi over 4 d squared. It will be like this. The P, its rule equal pi d, and it will be d. Delta temperature, it is a TB, T body or T surface. It's the same, minus T environment or T atmosphere equal 50. You make direct substitution and it will be easy. Okay? For the second equation, second problem, it's also direct substitution. We can read it together. A long thin copper rod 5 millimeter in diameter. يبقى the diameter equal 5 millimeter times 10 power negative 3 to change to meter. Okay? Is exposed to an environment at 20 degree. Environment, we said that the surrounding equal environment, so the T infinity equal 20. The base temperature of the rod is 120. The base temperature of the rod equal 120, it will be the TS. And he gave us the H and the K, thermal conductivity in conduction and in convection. And the required is the heat transfer rate. So the solution, first of all, we recognize the problem is talking about rod. Yes, it's rod. We make the equation for the rod, and we make direct substitution to calculate the area, the parameter, and the delta temperature. I think it's easy. If anyone has a question, contact me. Okay? For number 3, a straight fin of rectangular profile. So the first thing you write in the givens, it's a rectangular profile. You write like this, it's a rectangular profile. Has a thermal conductivity of 14, therefore K will be 14. The thickness is what? The thickness equal 2 and the length 23 millimeter. So the thickness equal 2 millimeter multiplied by negative 3 to get the meter. The length equal 23 times 10 power negative 3 equal meter. In case of the corrected length, as I mentioned, you can calculate the corrected length LC, or you can make assumption that the actual L equal the corrected length. It's up to you, both are right. But for me, I prefer that you answer with the corrected length. It is preferred to answer with the corrected length. So here, you need the Q equal, in case of rectangle, HPKA, delta T, tanh MLC. M, we will calculate M equal H root HP divided by KA. So, we have to study the cross-sectional area equal W times T. That, as we mentioned, W or Z, both are the same. It is the width of the fence times the thickness. Here, anything is related about the width for the fence? No. So, we will make assumption that Z or W equal 1. We calculate the A, then we calculate the P. In case of the rectangular, that P equal to W plus T. And also it's not assumption, it will equal A. So we calculate the P, we calculate the M, the corrected length we calculated. So, and then we make direct substitution to calculate the Q. The last problem here is a straight aluminum fin of triangle profile. Here is triangle profile. So the first thing you make that it is triangle profile. Written that the has a base maintained at 200, so for the TB or TS is equal to 200 degrees centigrade, exposed to a convection environment at 25, so the environment is equal 25, right? With a convection heat transfer coefficient 45. Okay? The fin has a length of 8 millimeter. يبقى therefore L equal 8 millimeter, so we multiply by -3. And a thickness T equal to pound. What is the required? Calculate the heat per unit depth of the fin. Calculate the Q. Q equal, in case of triangle, Q maximum time multiplied by Q fin. We have the delta T equal to 100. We have to calculate the Q max first. Area for the fin multiplied by T. Area for the fin, it's root T squared over 2 plus LC squared, all multiplied by 2. In this case, we make assumption that a length that LC equal the corrective length equal the actual length. And we calculate for the area for the fin, we calculate it equal this. Then we make assumption that the assumptions, or if the efficiency is not required, we make that the efficiency equal 0.98. We make a direct substitution. So the Q fin, we got it. Okay? If you have any equation, here is not delta T. It's TS equal 200 and T infinity equal, I write it up but by mistake. So T infinity equal, it will be, if you want to calculate, T equal be 200 minus 25. Okay? If you have any question or anything, call me. Wish you best of luck.